In this video, we're going to see how we can orchestrate Docker containers using Kubernetes. We're going to see what challenges Kubernetes solve for us and how to deploy Docker images as so-called pods. And we're going to see how we can access these pods, these workloads, using services and ingresses. And then how to use deployments and how they support us doing zero downtime deployment. And we're going to see how we can configure applications that run in a cluster and also how to troubleshoot and debug these applications. So in the first video, we're going to see how we can deploy Docker images as Kubernetes pods. We're going to see the rough concepts behind Kubernetes, how to use the kubectl command line, and what these pods resources are. And we see how to run our Docker images in a Kubernetes cluster and how to define resources using YAML. So Kubernetes is a so-called container orchestration solution that was originally built with a production-grade, behavior in mind. So it was originally built and developed by Google and then open sourced a couple of years ago. And this is now a project, an open source project that has a lot of traction. So there's a lot of development going on. And what it does, well, it orchestrates containers. That means now we in production want to run our Docker images to containers, not only on one physical node, but on many nodes. And these nodes, of course, need to be orchestrated within a cluster. They have distinct IP addresses. They need to be accessed from somewhere using proxy servers and so on and so forth. And all this orchestration, all this configuration of the whole cluster is now done by our Kubernetes solution. So that is one solution that already solves a lot of challenges for us that we then do not have to do ourselves, similar to Docker. And now we're going to briefly see the architecture behind that. So we have a couple of physical nodes that are all part of a Kubernetes cluster. And these nodes are the actual workload. So they run our Docker containers later on. And these nodes are orchestrated by a so-called Kubernetes master that is accessed via a single entry point via a single API. So we as developers can access that Kubernetes master and then transparent to us developers, however the cluster situation looks like, it will deploy and orchestrate the workload for us and deploy our images as containers to individual nodes. And to get a better idea of how that works, let me show you an animation, how we define several nodes that are part of a cluster. So these nodes are the physical hosts that are grouped into a Kubernetes cluster. And these nodes are then the actual workers that run our workload. So in these nodes, we run our containers, and the containers are defined as so-called pods. So a pod is an atomic workload in Kubernetes, and it defines one or more containers, usually a single container that runs in a pod. And these pods then need to be accessed from somewhere outside of the cluster, or also inside the cluster as so-called services. So we define a service as an abstraction over these pods, over these workloads, that then makes these workloads accessible from either inside the cluster or outside the cluster. From outside, we can use so-called ingresses to use, for example, HTTP to access our workload. And now the services are, of course, also accessible from inside the cluster. So that means if one container needs to talk to another container or more like to another service, then we use these services also for cluster internal communication. So we define another service, let's say, that may forward to another single pod, depending on how much replicas we want to have. Let's say we have another pod here, and then our service forwards to that pod. And now the service will be accessed potentially as an external system from another pod. And this is then how we can do internal communication, external communication for workloads that are deployed to a Kubernetes cluster. And now to showcase this, let's see how we can define these resources. So we have our coffee shop Docker image here, and now we want to deploy that to a cluster. So I have a cluster running here on my machine that we can access using kubectl. Kubectl is the command line that we use to access a Kubernetes cluster. It's configured to use, a cluster that is running on my local machine here. The cluster actually only has one node, but that doesn't matter for us. And we can use kubectl get, the get command, to get us, well, all kind of resources, resource types. And one type is a pod. So we can ask to please give us all the pods. And now, well, there's nothing running. So there's no workload running right now. The cluster is basically empty. So that means now we want to, well, run our coffee shop, run our Docker image as a container. And in order to do so, similar to the Docker example, we now write infrastructure as code. That means we define all the cluster as code definitions, in our case is YAML files. And we write one YAML file for our coffee shop deployment. So now we write one specification how to, well, deploy a pod. So let's call this coffee shop. This will be a pod definition. And now we point to an image that is our very image that we built and pushed before. And that, well, needs some specification. We basically say we have one container later on, or we have one container in our pod that runs this image. And we need, well, a secret to access our private registry. That's another story. And then that's basically it. So these YAML files are object definitions, quite similar to JSON, where we always have some kind, that is basically the type of the resource. And then, well, some metadata. We always will have a name. That name is unique per resource type, so we can only have one pod coffee shop. And that runs, well, this specification. And now we can use the kubectl command line to run our workload. So we can say apply, please apply everything in that file. And now Kubernetes will go and look into this file and see, well, now our pod is created because there's one pod definition of a coffee shop pod, and this is unknown yet. And now if we look again into the get pods, then we have one pod already that is ready and running since 10 seconds. And well, now our workload is running in our cluster. And in the next video, we're going to see how we can access this.